Yeah.
All right, everyone. Welcome to this first session on the Codecamp Romania, the one before Christmas. I'll be taking the next 45 minutes to take you through the new distributed application runtime that is being built by Microsoft and how you can build distributed applications with .NET Core. I'm Alex Thissen. I work in the Netherlands and also live there at a company called Xpirit, where I do cloud architecture and involved with a lot of technology and new technology that is emerging and ready to be used. So let's talk for the next 45 minutes. Quite a bit of things that we would like to discuss, but the end result should be that we have a user interface in a web application that shows all a top 10 list of Twitter accounts that are mentioned in conjunction with a hashtag Microsoft tweet that will pop up during the day. And we are going to build it up in as a distributed application. So in terms of separating front end and back end, there's a Twitter monitor that does the actual monitoring of the feed with all the Twitter messages. And there's a separate part that does the back-end processing. And in this case, it's a specialized component that takes care of what Twitter handles were mentioned most during the day with hashtag Microsoft. And it offers an API that the front end can use. The front end is a Vue.js application that will connect to the back end. We will do some storage in Redis state store. And we will use, because the direct communication from one to the other would be possible, definitely, but we'll take it a step further and communicate over a publish subscribe pattern with Azure Service Bus in this case. And we'll also use Azure SignalR server because we want to push updates to the front end and notify the web application that the top 10 list has changed, so it can refetch all the data and show it, so it doesn't have to do any polling over time. So this is what we'll do during the presentation. So we have an overview of what was happening there. But first, let's get a bit of background there, and I'll be reasonably fast here and point out some of the key features and not dwell on things too much. But you might have noticed that there's also service meshes that have been introduced when you work with mostly containerized hosting of distributed applications. And I think that the big distinction between service meshes and Dapr as a distributed application runtime is that the service meshes are mostly geared towards the infrastructure and the networking layer for operators. And in the end of the day, it doesn't really give you a way to interact with the service mesh. It's there, it does its job from routing to flow management with A/B testing, the metrics and the tracing, that's all there. But you can't influence it from a programming side. And that's where Dapr takes a different approach and says, okay, if we are like this runtime that behaves a bit like a mesh and it's covering all of your distributed application parts, we can do additional stuff for you. And you can interact with Dapr as a runtime and incorporate that into your program. That makes it different from Istio, Console, Linkerd, because they are mostly on the service mesh side, and they can be combined. So you can choose you can combine them and then choose whose metrics and tracing you would like to leverage. Dapr itself is written in Go, but you can choose a variety of languages that allow you to write the code that interacts with the Dapr runtime. We'll be focusing on .NET Core. And the Dapr provides this set of building blocks, is what I'd like to call them, split into capabilities, the things that you get for sure, and components, which you can choose to your liking, and you might not need all of them. The capabilities are the way that you can make calls from one Dapr component to the other, and the actor programming model, and the components are things like input and output bindings, storage, there's key management, there's tracing involved. Well, a lot of things that you can do, and we'll cover quite a few of them. Dapr-based applications can be hosted anywhere, from the major cloud providers to everything that is on premises. and it doesn't really matter which one you choose. And on top of that, let's say you would pick Azure for hosting your application, you can leverage the components from each of the other ones as well. So you can mix and match hosting in Azure, but having your state storage somewhere else. That would be viable scenarios. And the beauty of the Dapr is, and we'll get to that, is that you can also swap that around quite easily. So you have a very portable application once you build it using Dapr. Now, the way that Dapr provides you all of these additional capabilities is with a sidecar architecture, where your application knows how to expose itself. So there's a sidecar provided by Dapr that can start this direct communication with your application. And it's almost as if you're attaching the sidecar to your application, and the sidecar can become your entry point for the application and do things to you for you, because the sidecar knows how to communicate with your application when things happen. For example, incoming Twitter messages. Now, this is non-invasive, so you won't notice too much of Dapr doing its things. You will still be building regular .NET Core applications, but taking into account some conventions and ways of interacting. Now, if you run this in Kubernetes, that's the production level of running Dapr. Things go into the Dapr system namespace that are related to Dapr being able to perform all of the things that it needs to do, from injecting those sidecars to doing actor placement for the actor programming model, and then other things for Sentry and operators for monitoring when certain building blocks have to be attached. Your application will be hosted inside of a container. You will build a container image, and when you create a deployment manifest, you will add special annotations that indicate that your application needs a Dapr, that it's Dapr enabled, and some specifics on how it should be enabled, like port numbers and application names. And that's when Dapr takes over. It will use the sidecar injector, because when your application is deployed and it's started, it will notice that it is Dapr enabled, and it will inject the sidecars into your pod, so they are closely together and can start communicating. And for each of the other application parts that are there as well, more sidecars will be injected across. And because the sidecars know about each other, they can do secure communication through MDNS and MTLS. Now, and whenever you need one of those building blocks, they can use all of the building blocks from the sidecar, and the sidecar will do the heavy lifting. So in your application code, you don't need to know much about the details of publish subscribe technology, or in our case, the specifics of input and output bindings to Twitter, for example. Now, if you would take a bit of a closer look, and then we take all of these building blocks and we pick our application code, then the application code will communicate with the sidecar through the Dapr API, which is a set of endpoints that are available. And your application code, if it knows which endpoints to use and which data to send, can talk to the sidecar as a means of using all of those building blocks. So the Dapr sidecar is more of an intermediary representing all of the building blocks. So you don't have to know the building blocks in detail, and it's abstracted away. The various endpoints, as you can see, like the state and publish, they correspond to state management, publish and subscribe. And all of these go with one of the building blocks. And there's a specific set of HTTP commands that you can send with relevant HTTP verbs, but that allows you to do certain things. For example, put something on a queue would be done through publishing on the v1.0 publish and then sending your payload. And the sidecar will take care of putting it on NQS or the Azure Service Bus, for example. The endpoints that are available are two different kinds. There's gRPC that you can use, and you can also leverage the HTTP endpoint, whichever one you prefer. The HTTP one is obviously a little bit easier to access. And the Sidecar process is dapr-d.exe that will be started once a Sidecar is starting to run. Now, for each of those components that you can use, like I said, it's abstracted away, and you don't need to know about all of the details of how to connect to them. And that allows you to do a whole variety of components. For example, publish and subscribe. These are the ones that are there, and the list is growing because to Dapr these are community contributed implementations of the various components. There's also the ones for state management, the resource bindings and triggers. We'll get to that later. That's also an impressive list. We'll have Zipkin and open telemetry for distributed tracing, and a lot of implementations that cover the various secrets. And all of these are provided for you to be used in a declarative way. So a text-based YAML file will indicate which ones you would like to use, and they are automatically hooked to your application through the sidecars. And the way that happens is in declaration files, 3 different kinds. The components specify the individual components that you would like to use. And in this case, it's a Zipkin trace exporter that has some metadata in YAML format. And then you will have a single configuration file that specifies some details on how to specify, well, the tracing is most of what can be configured at the moment, but this will be changing in the near future with release candidate 2. And then finally, if you go to production and have a Kubernetes deployment manifest, you will need those special annotations that I previously mentioned, which you can see here. That say, is this one Dapr enabled, meaning that it needs the sidecar. It has a unique identifier to distinguish it from other parts of your distributed application. It has a port number for the communication to your application, and it has a reference to the configuration with appconfig referring to appconfig as the name of your configuration that you hooked up. And then you start specifying all of the containers and the images that you need for your application. Now, getting up and running. If you want to do this locally, you would need to install Docker, obviously. It will give you the Docker tooling, and even if you want for your testing a local Kubernetes cluster, you will need to install the Dapr command line interface that allows you to do a lot of things both locally and once you have things running in a Kubernetes cluster. And finally, you will take a step to initialize the Dapr runtime, making sure that certain images are being used as running containers, for example, for state management locally. But also, if you want to do that for production in Kubernetes, you can deploy Dapr with the CLI. A better option would be with Helm 3 charts, because they provide a more robust way of configuring more of what you would like to have in the end state. Now, if you want to run with your sidecars locally, the way this thing works is that you have the Dapr CLI to start and stop instances. And this would be a typical command line, and we'll be using that in a moment, where you say Dapr run and you specify the ID of the application, the port of the application it needs to attach to, and a special path to the components that you would like to use. And that components folder should be located inside of your well, your deployed application. And if you're still doing development, it will be most likely inside of your project. With all that pre-configured, you can start your application directly with the aid of Dapr, the Dapr CLI, and that will automatically hook up things. So the sidecar will look at the components, inspect all of the YAML files, and there can be multiple YAML files. All of the components will be collected and provided to your application. And then your sidecar that is started will wait for your application to be running at port 5000. It's .NET Run in this case, which starts the application from the context that you're in. And once that your application has started hosting and provided the endpoint at port 5000, the sidecar will be available and it will expose its own Dapr API endpoint, and your application can start connecting to that as well, and you're up and running. And this is what you can do locally. And the beautiful thing is that it's mostly the same in production, except that you don't have all the debugging tooling there. But you would even be able to debug in that situation. Now, since we're going to build a .NET Core application, it's important to understand that, well, things stay pretty much the same. You know that from ASP.NET Core, because we're building a .NET Core application with HTTP endpoints, that you will get all of your builder extensions, and you get some more with Dapr and the Dapr SDK. Distributed tracing you get for free. You have your state model binding, just as you would do model binding in ASP.NET Core, but then to the state management on the Dapr side. Your PubSub it can be taken care of with middleware and other registrations and routing that you do. You get an active programming model, you get extensions for configuration, and you get a special Dapr client that makes it easier to communicate with the Dapr sidecar endpoints. Not having to know that much about the endpoints with the v1.0/publish and knowing the exact details of the payload. That will be taken care of by this Dapr client. Now, back to our application here. We'll go through this and we'll start at the bottom with the input binding of the Twitter stream that has hashtag Microsoft tweet messages. And whenever a message arrives, we want to receive that in our application and take action. The input and output bindings, there's a list here. It's not a complete list. There's more binding and triggers. And these are much the same like in Azure Functions, if you might be familiar with that. And what you would typically do is you define a component, give it a name, and pay special attention to the name of this component, which is tweets, because we will see that in our application code. And then you specify the type, which is a binding of type Twitter. And related to a specific type, you will get specific metadata, name value pairs that relate to this component. And in the case of Twitter, you will need to register yourself as to be able to access the Twitter API. You get keys and secrets and tokens, and you will specify those there, and then at the very end specify the query of the filtered stream that you want to subscribe to. Now, whenever a message arrives, it arrives at the sidecar, because the sidecar reads the YAML file, knows how to bind. And when the input arrives, it needs to dispatch that to your application. And it was the name tweets. So we will see in our code that there's this tweets endpoint that we will provide from our application side. And that means that your application still listens to HTTP, it receives something on /tweets, but it means that the Twitter message has arrived, and we can start handling that. And there's two ways. One is a very raw way where you just define an endpoint and map it to a handler method, or you can do it from a controller method where you can even do model binding to the incoming data. So there's this tweet class that will automatically be populated with all of the incoming data that is pushed from your sidecar. Now let's see that in action. We'll take a look at the Twitter monitor with the sidecar and then doing the input binding to Twitter. So let's quickly go to our application code. This is our code. I will stop this for a moment. And let me show you the application here. This is the Twitter monitor. And inside our monitor, we have the program CS, which is pretty standard. Let me increase the font just a little bit. It has the boilerplate startup with the host builder, and it uses the startup class to do the rest of the bootstrapping. And if we take a look there, it's nothing that special. This is where the things get interesting. Here down at this point, we're doing a listing of an endpoint with a post that listens to this tweets endpoint. And the tweets endpoint is doing this input binding to this message here. Let me get rid of all of these things, like so. And this tweets message here, the tweets name of the component, will be used in this startup. All right. Once that arrives, it will call this, it will do this post and push it to this handle Twitter message, which offers you HTTP context. And the context will do a deserialize by itself. You need to do a little bit more work here than when you're doing the controller method binding. But in this case, we can see that we do a little bit of logging here and telling it that the binding for Twitter has an incoming tweet from a certain person. And later on, we'll do something more with publishing this. We'll get back to that later. But for now, we get the incoming message and we receive something. All right, so with that said, this is all compiled, and in this message here, this window here, I have the Dapr CLI. As you can see, I'm using the release candidate version number 2, which is the one just before the 1.0 release. The runtime is still at RC1, but that might change this very day or maybe in the very, very near future, because they're revving fast. And now finally, we will use that command line with Dapr run to start the application. Our hosting is at port 5000 for the application, which is the default port for a .NET Core self-hosted application. And let's see what happens when we start this all up. That's interesting. Let me switch to a command prompt and try it there as well. Oh, sorry, I know what is happening. Let me do that quickly. I was in the wrong folder, and you do need to have your application running there. Let me try that again. Open folder in the File Explorer. This is our, go there. This is where I have everything listed. So there's the Twitter monitor, and then we can do Dapr run from here, and that should be working a little bit better. So there we go. Let me move back just a little bit. At this point, it said that it was waiting on port 5000. That was the yellow output is from the Dapr Sidecar, and that says, okay, now we need to be waiting for your application to get started. And this is where you see the bootstrapping of our application in blue. And then we start hosting at 5000. And immediately afterwards, it says, okay, I've discovered the application at 5000, and then it will do the rest. Our application is already receiving Twitter messages, as you can see, because it arrives at the sidecars, pushed to our application, and here we do the logging that we saw with a tweet coming in from somebody. So we are actually at this very moment seeing people being mentioned in conjunction with #Microsoft, which is good. So this does all work on a local hosted standalone way of running for development purposes. Now let's stop this and go back to our slides to do the rest, because now we're on a roll. We are able to receive Twitter messages, and now we need to push them out into the PubSub infrastructure so our backend can start handling it. Now, before we start building that, it's important to know that our Dapr client is a separate NuGet package, which is in a certain version at any point in time, and we will use that. It's included as part of Dapr ASP.NET Core, and I assume that most of the time you will be using that NuGet package and you automatically get it included. And what happens is with the Dapr client, you get this proxy that is strong typed, so you can use regular methods with the NuGet package in the client. So you actually have a means of communicating with the sidecar differently from using the raw HTTP or gRPC endpoints. And if you want to use that, you need to add the NuGet package to your application code. You need to add the reference to the Dapr client as a registered dependency injection mapping. And there's more configuration that you can do influencing all of the options, just like you would normally would in your startup class. And then finally, if you have all of that available and you want to start using the Dapr client, you can have it injected via the constructor, which is standard practice, I think, in .NET Core, or with method injection. And that's actually a nice thing because you might not need this Dapr client on each of the controller methods. But if you use the constructor injection, every controller instance will get this Dapr client injected, but it might only be used in a few cases. So in that scenario, you might want to inject your Dapr client with the from services annotation into the specific controller methods. And then you can start using, as you can see at the top, you can use the Dapr client and use all of these async methods that represent most of the building blocks that you would like to communicate with through your sidecar. Now, publish and subscribe uses a message or event bus of a particular type. It can be any of the ones that were listed. Here's just a few of them. And your sidecar will do all of the detailed communication. And you will just call the publish endpoint of the sidecar, and the sidecar will push out a message with a certain payload onto a particular topic that is received on the other side with 1, 0 or more subscribers on the other end. And again, it's the sidecars doing the subscriptions to the bus and receiving the messages and pushing them out to the subscriber code, much like from a Twitter message. So in that sense, you can almost see it on the subscription side as an input binding to a bus. Now, the inside of the payload uses a cloud events envelope that contains the actual data in this section here called data with the data that we actually want to expose. There's also the 0.3 specification. You can switch between them if you have legacy applications to support. And the way you would publish them is, most easily is, of course, with the Dapr client and using a method publish event async, where you specify the name of the component and the topic that you want to publish to, and then the payload, which is your DTO, your data transfer object that you want to push out. And on the subscription side, you need a bit of middleware. We've used cloud events to do the unwrapping of incoming messages to get rid of the cloud's events envelope, getting out the inner data. And you need to expose an endpoint that is at /Dapr/subscribe with a special JSON format. So the sidecar, when it evaluates your subscriptions that you want to have, it gets this /Dapr/subscribe endpoint and receives a list of all the topic and routing information that you want to subscribe to. And with that, you have pretty much the same as we saw with the input bindings. You map a certain topic to an incoming route. The two of them are split up, so the name of the topic doesn't have to correspond with the actual route of your implementation, but it can be either with the endpoint configuration in the startup, or it can be with a controller method that follows a certain convention, with again strong type binding to the data that is being delivered, and also with an attribute that is specifying that this is one of the things that it takes care of the subscriptions. And this will be exposed, this combination, with the /Dapr/subscribe if you use the map subscribe handle method. Now, before we go into the next demo, a little bit about state storage. The raw way would be to do post, gets, and deletes on the endpoints. And then you can leverage, Cosmos DB, Redis State, Cassandra, and many, many more. Defining those components is pretty much the same from here on in. In this case, it's a type that is state dot and then the exact implementation, Redis, for example, and you will have some metadata there that you can use. The implementation takes care of consistency and resiliency, so it's pretty okay and robust in its way to store the actual data. And you can have multiple stores, and for each of the stores, you will have a different component definition. They can be separate YAML files, they can be put together with the -- separation. But this is a way to have multiple stores, and just by knowing the name, so the name state store is again relevant, because that allows you to switch between state stores whenever you store something. All right. Binding, that this is the strong typed model binding. Notice that it has this state entry of T, with T representing the data that you want to store. You can get it from a certain state store in this way. Well, in a Dapr client, you would do something similar. All right, so let's do this part now. We have the sidecar on our side. We just received the message. We will push it on the bus and then push it down into the sidecar again. And then store it in a state store. Okay, let's do that. Well, we were already here. We just received the message. And then we will do this publish event async. And it will publish something. In this case, on a component that is called message bus in a topic called mentions. And I'll show it again at the risk of again showing some of the details that were available. Well, we're pretty good here. Here we have the name of the component message bus. It's of type PubSub Azure Service Bus, and it has Azure Service Bus specific details in the key value pairs. And this is how easy it gets. Well, you would almost say can't get any easier, because in your application code, this is all I need to know on how to publish something on the Azure Service Bus. And the wonderful thing is that if I change this PubSub file and change this to something like from Azure Service Bus to, let's say, RabbitMQ, then all I need to do is provide additional connection data, and I don't have to change any of my implementation code, because the same code will push it onto RabbitMQ from here on in. As you can see, we store the entire data of the incoming tweet message into this event type class tweet received, including the monitor tag, and the monitor tag comes from configuration, and in our case, it's Microsoft. That's the hashtag Microsoft that we're following now in this stream. And then on the other side, we have this leaderboard web API that has a pretty similar startup. So the startup here has a little bit more detail because of the extra bootstrapping. But in the startup, we will see similar things. So for example, we have the cloud events, we have the map subscribe handler here, and the rest of the code is taken care of in this most mentioned controller, because that has the logic on how to handle an incoming tweet. And in this case, we want to see who is most mentioned. Now, here we have a method, a controller method with the annotation. So this is the one that will be called. And it has this tweet received message that we will use, and we will upon its arrival, store it in session state. Sorry, not session state, in the state store. That is, well, we should be able to see the component that is used there. That is the state store here, and it's Redis cache. And this is how you start working your way towards doing things. There's some logic here with actors. We'll get to that in just a second. But now we need to have the other component running as well. And you could do multiple startups from the command line, but it might just be easier to use Docker Compose. And from the Docker files that are inside of each of the projects, standard Docker files that are non-hardened, they will provide a container image that we can use and then compose everything. And the trick that is being used here for locally hosting your multiple component parts with a sidecar without a cluster is that we have this special second running instance with an image from Dapr IO Dapr-D that is being attached to our own code with this networking mode that says, okay, this is what's going to be running next to the service called Leaderboard Web API. And the Leaderboard Web API is our hosted code for the second project that we showed. And there's a similar one here for the Twitter monitor, with the Twitter monitor using the Docker file to build, and has a separate sidecar with Dapr-D to be attached to in a intimate networking mode that is connecting them very closely together. And then you can do all these other things like hosting Redis. You can do AI forwarders, Grafana, Prometheus, all the things like Zipkin and all that you can put in the same composition. And when you press start on your project, it should all spin up and get this distributed application running. So let's see if that all works. The bar turns red, so we're in debug mode now. We'll go to the logging that is now appearing inside of this here. Our application has started, and with a little bit of luck, it should have the same incoming messages on our application. In the Leaderboard Web API, if we start looking there, you can see that there's already a Twitter message being handled. Now, the same application also has a web API, and I won't be able to show you everything in time, but the leaderboard controller is offering a HTTP GET on most mentioned, and it uses the actor programming model to get the data from a certain actor. And as you can see, there's Twitter messages coming in at the bottom here, so that's all good. And we should be able to go to our application here. And this application, let me refresh just to make sure. This has the current leaderboard, and whenever a new message arrives, it's being pushed to this front end. As you can see, the toast message is appearing. Leaderboard has been updated, but not apparently in the top 10 of the board, but sometimes you see them show up here. Well, how does that work? And let's do a little bit of a code walkthrough to look at the other things. On the most mentioned controller, we work with the actors. And the actors, they have this programming model to make sure that there's serialized, single-threaded access to an actor object at a point in time. We have a distributed concurrent application, but whenever we want to store information about our top 10, we don't want to have race conditions or concurrency issues. And this actor programming model uses an abstraction iLeaderboard actor, which describes the form and shape of how to interact with the actor. Now, we're storing the top 10, a top X list of Twitter messages and people being mentioned. So we're submitting scores and we can get rankings. And the implementation of that is using this class leaderboard entry with the individual entries in the top list, which is maxed out at 10. And whenever we submit a score, we can use the state of the actor, which is using a state manager where you can get state from, and we're getting a list of those leaderboard entries with a particular name ordered list. Now we do some little bit of logic where we say, okay, there's this new leaderboard entry because we're counting the number of times that we saw someone, and whenever if we order it ascending and we take the top, well, in this case, the top 10 list, we store that as new state of the actor again. And the actor has is partitioned to be using the ID, and the ID of the actor, as you can see here, is using the message tag, which was Microsoft for #Microsoft. Each actor will represent one of those lists, and you can monitor let's say Xbox or PlayStation 5, and you can monitor all of these things together, and each actor will represent and hold the data for each of these things. Well, once we have a proxy to the actor, we can do logic that says, okay, we have an incoming Twitter message. Let's see how often we already saw that. We saw it once more for each of the user mentions that is there. And then we write it out again by submitting the score via the actor. So we get this nice guarding of the concurrent access. And then finally, we get the ranking. Well, we wouldn't have to need to do that, but anyway, we're sending out this notification over Signal R, where we're invoking this binding and pushing out the data that there's a leaderboard updated event occurred. We don't send any data. That would be an optimization with just the changes of the top 10 list. But in this case, it's just a signal something has happened in the leaderboard because we got an incoming message. And that's what you would see happening here, that every now and again there would be this toast, and even like so now, where there's something changing in the leaderboards. Okay, since we are running almost out of time, let's do a bit more of slides there. We talked about the actors, so I'll skip over them, and the slides will be available. We did the demo for actors already, and then finally, we saw the output binding of Signal R, which pushes out the things from the Dapr sidecar into whatever is the output binding. And there's two-way output binding, so it can go back and forth. There's quite a list at the right-hand side here. So there's many things that you can bind to, but in the demo we've used Signal R to push it to the front end. It's a little bit too much for the time to go into that, but since the source code is on GitHub, I can recommend you to look at the implementation. It's just a single HTML file with a little bit of Vue code that does the binding to the API and gets notified with the Azure Signal R server. And finally, the last thing that I can show you is, with all of this prepared, and we did minimal coding because you saw pretty much all of the code that is there. How about tracing? Because Dan mentioned it, you know, if things work, it's great, but if it doesn't work, you want to know a little bit about your application. You need to have instrumentation and monitoring set up. Well, in this case, as you can see, you only need to define the component for the tracing, and then everything is taken care of for you. You don't need to spend a single line of code to do any of this. And well, what can I say? I can show you that with all of this prepared, oh, and this is just a new entry that arrived. If we go into Zipkin, that is also being hosted, and we run a query here, we can see everything that is happening under the covers. And we can open one of these up and even show all of the details, where you can see that something arrived at the Twitter monitor. It's being pushed out on the pub/sub mentions topic, and down here it's being accepted and pushed to submit score for the actor, and then finally invoke binding of the Signal R, where it's pushed out to the front end. So all this distributed tracing you get for free, and you can even see the dependencies. And if you look at that, you can see all of the messages flowing from one component to the other. And in our case, it's just two, so that's pretty simple. But if this becomes more distributed and many moving parts, then you can see the whole topology of your dependencies going back and forth. With that, I think we're pretty much at the end of the session. We did the demo for the tracing very quickly. And that's where I would like to finish the presentation and go back to Dan for a wrap up.
Thank you so much, Alex.
Hi guys. Well, great to be able to do the talk here, and I hope you have a good, nice rest of the conference with the other three speakers.
We will, for sure, but before that, we've got some questions from the participants.
Okay, let us have it.
Yeah, okay, so one very specific question is the following. Will Dapr run on Kubernetes 1.2 or 1.20?
That I don't know the answer to. Well, that's very, very specific, but if the person in question can reach out to me, I can certainly look that up. Or you can even ask the team yourself, because they are very reachable at the Dapr dev community. And there's a new Discord server where you can join the discussion and ask all of your questions. But feel free to reach out to me as well.
That's great. The other question is, what's the advantage of using gRPC instead of HTTP?
Well, gRPC in general is a more modern and more optimized protocol that is binary in nature, so it's more efficient for internal communication. And since this is not exposed to the outside world, it doesn't limit you in terms of reach, but does offer the better performance.
Very clear. And the last
one is, does it do hot reload of the configuration, or does it require a restart?
Okay. I think that if you're doing this from local hosting, then it does need a reload, a restart of your application, but it would be just stopping Visual Studio and starting it again, or doing the Dapr run from the command line. If it's in your Kubernetes cluster, you would need to do a redeploy of your application. And I'm not entirely sure about the hot reload of the config files, but I think because this is related to the internals of Kubernetes, that it's out of reach of your application code. So it can't know of the Kubernetes environment changing versus your application code running in it. So I would assume that the redeployment will make Kubernetes do all of the restarting of pods because it affects your deployed application.
Excellent. And I've got one more question. How do you see the adoption of this toolset or runtime?
Yes, I think that adoption will start occurring more and more now, because it has been an alpha release going from 0.1 last year to 0.12 now, and now we are at the it's being renamed to the 1.0 release candidates. I think with this new technology, there's a certain type of applications that will benefit from this setup, and with a released version, people will start using it. I think I was a little bit early just a couple of months ago, but now I think adoption will start occurring, because it does take away a lot of the plumbing and will accelerate your application development, especially difficult things like distributed applications.
Super. And before we conclude, the last question is, what do you plan to do for Christmas?
Well, I plan to spend the Christmas with my family. Well, in lockdown, unfortunately, the Netherlands has gone in lockdown since yesterday. But that will be a good time to spend time with the ones we love, and do some nice cooking and playing board games, for example, video games. Will be a good time.
Yeah, sounds like a very good plan to me. Thank you so much for being with us at Codecamp, and we're looking forward to meet in person very soon, pretty soon, we hope.
Yes, right? Hope the same. Wishing you all and all of the attendees a very wonderful holiday season and Christmas time, and a happy new year ahead of time for January 1st.
Thanks, you very
guys.
much.
Thanks so much.
You too.
Bye-bye.
Bye-bye.